In this video, let's look at what is the traditional flow of creating a training pipeline and what are its drawbacks. We will also see what are the constituents of a good training pipeline. There are broadly three things people do while training a model: ingest the data, do data exploration and prepare features, lastly, train and validate the model. Let's look at how traditionally data is ingested. One usually has a code in a Jupyter notebook, which makes it difficult to run ingestion code outside of notebooks. We also usually hard code the data sources in a Jupyter notebook. This makes it difficult using different data sources in future, as one will need to manually update these paths. Also, this closely couples a training code with the data sources. Let's look at the data preparation and feature engineering. You will usually have a code that sort of looks like this. One of the things we notice is in this part of the code, we are making assumptions about our data. We are assuming that a new data set will also have same column names and data types, which, as we all know, is not the case. Again, our code is in a Jupyter notebook, which makes it difficult to run in any other environment. Also, data preparation and feature engineering can encompass many steps, and the code execution in this notebook doesn't tell us which steps are being executed. Now let's focus our attention on the training and the validation code. We can see that the model hyperparameters are hard-coded in the notebook. This brings in coupling between the training code and the model hyperparameters. We are also not saving the model artifacts anywhere, and again, our code is being executed in Jupyter notebooks. Another drawback of the traditional approach is that there is no way to track which version of Python packages were used to run different parts of our code. Sometimes the dependencies are beyond Python packages. There might be some Java-based libraries that might have been used. In our current approach, there is no way to keep track of these dependencies. Let's see what are some of the things we might change in our current approach to tackle the issues we just raised. One of the things we've noticed is that in our current approach, there is close coupling between our code, data sources, and model hyperparameters. This can be resolved if we use a configuration management system such as Hydra. We've also seen that we are not doing any data validation. We can remedy this by using data validation libraries such as Pandera or Great Expectations. All our code has been in Jupyter notebooks. What can we do about that? Well, we can port our code from Jupyter notebooks to reusable Python scripts. Lastly, we are not keeping a track of our coding environment. That is, which Python version and package versions are being used to develop our code. We can remedy this by creating separate Conda environments or package each of our training pipeline into a separate Docker container.